Hello, and welcome to Data Unchained, a podcast series about making your data available to your most valuable applications and workforce in the world. I'm happy to welcome back Floyd Christofferson, who was previously a guest on our show, and continue a conversation about really making data a global resource that's easily accessible. Floyd, welcome back.
Thank you, Molly. It's great to be back.
So, Floyd, last time we talked, we kind of ended the conversation talking about the evolution of the ways companies have been trying to address managing this growth in unstructured data, how to store it effectively, how to access it effectively. And we were kind of tying up and talking about, okay, so there's a need to access data across storage silos. There's a need to access data on a more distributed basis, and got talking about the different solutions there. So what I'd like to do is pick up that conversation around global file systems. So global file systems, I know is a space you've spent a fair bit of time on, and the ways they've been architected has evolved and varied over time. Maybe if you could just talk a little bit about a global file system with symbolic links and without, what that even means and why it matters.
Symbolic links are kind of a bridge between file systems. So let's say I've got storage with a file system over here, and I have another storage type, and I want to offload my primary storage or my most expensive storage, but move that data somewhere else. The inertia that occurs, and the problem is that users are over here expecting to see a file in that store. And because the file system is locked into that storage at the infrastructure layer, now if that file moves over here, they're out of luck. So a symbolic link will, when the user comes in here, it will reroute them behind the scenes over to that different store. So a global file system would bridge both of those, so that in fact what you're doing is elevating the file system above the infrastructure layer. And just like NetApp pulled the file system out of the operating system and brought it up into the network, well, this would actually bring it above the infrastructure layer so that you could see both, and you wouldn't have that fragile rerouting of data across different storage types.
HSMs, data tiering solutions, those would be kind of examples of symbolic link technologies generally.
Yeah, they use a variety of different technologies. Some of them involve symbolic links. Some of them involve separating the inodes or the file, basically the metadata of that file and keeping it here, but then rerouting the file essence in the background somewhere else. All of these are, in my thinking, bandages to kind of try to patch over the fundamental problem of fragmentation of file systems based on the vendor storage types that they're attached to.
So customers would put a bandage like this in because they want to maintain costs, is kind of how I think about it. They want to add tiers in, lower cost tiers, only have the appropriate amount of data on high performance NVMe.
Yeah, I mean, there's a variety of different reasons. I mean, data migration is a huge disruption. I mean, the data will always outlast the storage it's on today. The storage itself will fill up, or it'll age out, or like you mentioned, you might need a different cost band for a different class of data. And so with the file system locked to that storage type, IT administrators have to do long scheduled outages, or they have to stand up whole infrastructures in at the ready to do this cutover. And now your users, they have to come into a different mount point, or their applications have to be rerouted. It's tremendously disruptive. And so this is where inertia plays in and vendor lock plays in as well, is because, well, I may not really want to keep all my data on this most expensive storage type, but I can't afford the disruption to move it to a more rational location.
There's probably two ways an IT architect thinks about their environment. There's storing and retaining their data, and then there's putting their data to use.
When the technology enables them to, those lines get blurred. So traditionally, people would think of active data and inactive data. So an active archive, for example, you may move your less active data to an active archive because it's lower performance. Maybe it's in the cloud, or it's on tape, or it's in an object store. And so now you've segmented your data. But as people are applying ML and other sort of data analytics to be able to monetize existing data sets, that becomes a problem, because now you've got different classes of data storage, different classes of data storage, where you've sort of gravitated these different classes of data. But the reality is, if you could have seamless access to it all, regardless of which storage it's on, regardless of which vendor platform it's on, you get more monetization out of your data, you get better efficiency out of the data, you even know what data you have and whether it's protected or not.
When the customer, an IT manager, whoever it is architecting a data environment, I think we all are pretty accustomed to looking at NAS vendors, file storage vendors for the storage bit. But there's another set of technologies that have come about that use the term global file systems. They're often embedded in cloud gateway appliances. Can you talk about those just a little bit? What are they? How do they map into this conversation?
There are many different ways, just like the word metadata, there are many different ways that people apply these terms. But typically, with the goal of this is to solve the problem that I just outlined, which is providing sort of a global view at data that might live in multiple places.
Do those global file systems solve the needs of storing data, or of creating metadata and interaction across different on-prem and cloud silos? Are they kind of limited to the cloud? Kind of where do people tend to deploy those?
You got to kind of peel back the onion on what they do. Number one, are they actually providing a seamless metadata layer that is looking that decouples the file itself from the storage it's located on? In other words, or are you looking at a metadata index that actually is of two copies of that same file? Or is it within a storage ecosystem so that now you're locked in with that? All three of those are sort of interrelated. But the common denominator of them all is that if and traditional data management is about copy management, data placement and data copy management. Because why? Because anytime you're moving that data, even if you've got a metadata index at the top, if you're dealing with forked copies of those files, you now have two different files that you're managing. Not much different than taking a floppy disk and handing it over the wall of a cube to somebody who installs it in their machine.
Okay, so you don't know where the point of truth there is.
Yeah, exactly. I mean, somebody else is going to change it, the file is going to change, and then you've got all kinds of mechanisms on the top layer maybe to try to reconcile that. But the reality is you're managing by copy, because the file system is still locked into the infrastructure of each of these different solutions.
So doesn't that add cost as well? If you're managing by copy, are you not doubling, tripling, kind of whatever the number of copies you have, the cost of your storage goes up, I presume?
Well, it's not only storage. I mean, depending on the analyst you talk to, you'll find that the operational costs are at least 5x the acquisition costs of storage. Why? Because they always have to be planning for the next migration, or how to bridge, or how to get better utilization. And I'm sure you, like everybody who's listening to this, has been in organizations where IT decided to change something and it disrupted your applications. It's now you got to learn a new system. And so all of these become impediments to effectively using the data, and those all drive costs up.
I love that you brought up applications. So when you think of these global file systems, how do applications connect to them? Is it something that IT is involved in? Is it talking to the metadata layer? How does it work? How does the application talk to its data as metadata?
Well, a file system, whether it's global or local, is a metadata layer that translates the raw bits on whatever storage medium it's on into a structure, into a file structure. When you look on your desktop and you see a folder and a little icon that looks like a folder, that is a metadata representation of raw bits on disk. And so as you try to bridge the underlying storage silos, in an individual box, for example, an individual storage vendor, you're bridging multiple platters within the disk systems, or multiple disk systems within a file system. Or some global file systems might actually create this representation layer that bridges some stuff that might be in cloud or on-prem. But the key here is, are you looking at truly that file system that's the same across them all? Or are you looking at ways to bridge the copies that you've had to do to really overcome these limitations?
Okay. So creating that single view of data not only helps with complexity of the environment, but just as importantly, probably more importantly, make sure the application is using the correct version of data and has access to as much data as possible.
That's right. That's right. If I've got my iTunes and I'm looking at music, I want to make sure that when I click on that music file, that it's playing directly. Well, that's fine for me as an individual with a few songs that might be in the cloud, it might be on-prem. But, now you go out on your phone and you don't have cell coverage. Guess what? You don't have that file anymore and you can't play it. But if you have
It's
a
super frustrating on
it's
a long road
it's
trip.
frustrating to everybody. You go over the hill and suddenly your audio cuts out. But what if, those now take that in a scientific environment or in biosciences, or if you're editing a movie or any number of different things. If you've now moved and you're having to bridge these across multiple areas and you lose connection to that metadata because you're dealing with copies, then you got a big problem. But if a global file system is the same metadata, and that's the key distinction, is it a true parallel global file system that is the same metadata, not metadata representations and copies, but the same metadata, then you're operating off the same file. If you're here, if you're there, if the storage is on, if your data is on this store or that vendor store or this cloud or that region. And that is a key distinction between things that call themselves global file systems and a real distributed global file system.
So I've been thinking about this concept of there's been something of a unrecognized missing link in accomplishing hybrid cloud, multi-cloud strategies that customers want. And as I've thought about it, I've kind of realized that what we've built up in the cloud is more storage silos. You have a silo in one region, you have a silo in another region, maybe in one cloud service versus another. And while the cloud has helped us innovate and grow in so many ways, there's still a bit of a missing link there on how do you knit this all together. Is the global file system the right answer? Is that how you do that?
If it's a global file system that can truly bridge any storage type and any locations, in other words, if it's a true parallel global file system that has the performance to create that, to decouple that metadata layer, to create essentially a metadata control plane above all of your infrastructure, then absolutely it is, because that's huge. If you've got this metadata control plane that can be accessible anywhere from any location, and it's the same metadata, the same file metadata, not copies, but the exact same file metadata, then your data locality is completely transparent in the background. Where it lives, when it moves, all of that is transparent. So to your earlier question about the applications, that application workflow never changes. You stage the actual file essence to the appropriate storage by policy, by workflow in the background, but you haven't interrupted user access. You haven't had to go through all of these mechanics to bridge the silos.
Okay, so that metadata layer keeps talking to the application, keeps continuity of the work, while in the back end, even if there's a data migration or a tiering job or whatever is running, that doesn't affect uptime of the systems, productivity of the researchers, whatever it is.
When you're working on your computer, you don't know if the particular bits that you're interacting with are on platter 1 or platter 2 or on disk 1 or disk 2. All of that is seamless behind the scenes because the application is interacting with the file system, which is on top of the storage. Problem is, when you leave that storage device, you're now in another file system. So now you've got two copies. What if you now could take that same efficiency of abstracting the individual disks and platters on your one computer, but do this across any storage and any location. That's what a true parallel global file system as a metadata abstraction layer is on the top. Now, data in the background can move wherever it needs to go, but nobody on the front side, no application, nobody needs to know where it is because it's where it needs to be at that moment.
That's super cool. So if I'm understanding this right, you could have an AI engine in AWS or an analytics tool in Snowflake access data that's sitting in a data center somewhere.
Could be in multiple data centers.
I noticed that you started using the term parallel global file system partway through the conversation. Why are you emphasizing that part, the parallel component? What does that mean?
This is not an easy problem to solve. I mean, a whole ecosystem of point solutions has emerged over the last 30 years to try to overcome and bandage, as I say, this fundamental problem. And one of the issues is performance. If you don't have that metadata, that seamless metadata layer with a performance enough, then there's going to be lags, there's going to be latencies, there's going to be all kinds of problems. And so the parallelism is required because you may have people at different parts of the world accessing data that might be in different parts of the world all simultaneously. And so the underlying infrastructure of this, which is why it's non-trivial to build this type of a system, these underlying infrastructure, the underlying mechanics of that has to be very high performance and inevitably has to be parallelized.
As you kind of think about the things a customer, whether it's an IT manager or a business unit owner, whoever it is, who's starting to look at these global data environments should be looking for, I would think it's, can you provide, like, kind of goal number one would be, can you provide a single view of your data? Goal number two could be vendor agnostic. And goal number three being that it's high performance. Is there something else that you feel like we should add into that list of goals?
Absolutely. Rich metadata. Being able to have custom metadata tags. And this is more than just tags, because part of the problem is, and in a previous life, when I would talk to IT, and one of the joys of my career has been able to talk to IT managers in some of the largest data centers all over the world. And I have a standard question I ask people, which is a bit of a troll question, but it's, so tell me about your data. How active is it? What is it? What kind of data is it? How is it being used? And all of these questions, typically, people don't know. And you go into an academic environment, it's even worse, where you may have shadow IT, where a grant funded a particular small NAS and it's sitting under the desk of a grad student who's just left. And they don't know what it is. They don't know if it's valuable or if it's not valuable, if there are IP in there they need to keep. And so, but without the ability to have rich metadata that identifies the files and then be able to set policies, especially objectives about how these classes of data that are related to a project or a department or a grant ID or whatever, a budget category. Without that, you've just got a big pool of data. And so as you listed through the important things, the ability to have intelligence in the data, it pulls it all together so that you can design policies that are specific to the data that you have and not just in a generic blob of data that might be valuable or not be.
That's a really great point. So the metadata layer is not just about aggregating the data sets across storage silos and making them available to the application, but and providing some intelligence about what that data is, maybe which projects it maps to, that type of thing.
Yeah, absolutely. And so metadata is a continuum. There's multiple layers. And so usually, if somebody says, well, we got metadata, well, what kind of metadata? And so it might be the file age, it might be the file name, it might be the path to the file, it might be the file type, it might be subsets within the file. You go to a NetCDF or other sorts of scientific files or DICOM files, there's huge amounts of data, metadata within there that a file system just can't handle. But if you knew which patient record that was, or what the lens setting or the firmware of the electron microscope was. That now enriches that data set. And so all the way up the stack. And if you can now have a system that can not only aggregate the file system metadata, but also reference and enable you to tag and intelligence on all of these other metadata types, now that is the holy grail of being able to really have a global data environment that is vendor neutral, is performant, can provide that continuous access, but then have the intelligence to be able to really drive how those data are used.
When I first started working in the media and entertainment industry and would go to the studios in Hollywood or in Pinewood Studios, wherever it was, you would see a room of essentially interns looking at video and assigning metadata. I don't know if you ever saw that, but got to see they were watching the sporting event or the movie or whatever it is and just madly typing the name of the actor, what was happening in the scene. Yep, exactly. And then when a company called Veritone came out, was one of the ones I saw that they could process these video files and create automated metadata. So you could just say, show me every car crash in a film, and those clips would come up. And is that what you're talking about, unenriched metadata?
That's one type of it, absolutely. I mean, scene detection. I mean, Google does that. Apple Photos will identify cats or whatever. But it's how do you make it actionable? So just the fact that you've got that metadata, if that's another metadata silo and it's not actionable related to the actual file, it's file age, it's file path, then you've got an interesting collection of metadata, but you can't really use it. And this is where being able to aggregate multiple types of metadata and make it actionable is really the key.
So actionable metadata layer so that the application can use it as well as the data itself and integrate it as part of this global file system. Makes perfect sense. Hey, Floyd, this is always so fun getting a chance to catch up with you. Great insights into kind of how the space is evolving. But I think in this episode, it was great to have some real clear areas that customers should look for as they're looking for architecting their next data environment. And I think this has become even more relevant through not just the cloud era as data has distributed across clouds and cloud regions, but now that humans are working remotely, applications are being innovated. I think I've seen numbers like 100 times faster now that you can do cloud apps instead of data center apps. So all of this seems really timely. I really appreciate your insights and hope to have you back as a guest again.
Good. It's been fun. Thank you very much, Mike.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.